Once again, good morning to all. Okay, students, the previous video we saw about the introduction to data structures. Okay, and also we saw some information about an arrays. Okay, how we declare an array in C language, how it's very useful. Okay, so that's our previous video content. Okay, so today we see about stack operations. Okay, stack and queue operations. So in this video, we fully concentrate only about stack operations. Okay, see here in this uh, stack and queue are very fundamental data structures. Okay, very fundamental data structures. Okay, so see in this presentation here they say ADD. Okay, stack is an abstract data type. ADD. That's a commonly used. Okay, used in most programming languages. Okay, it's named stack as it behaves like a real world stack. Okay. In the real world, okay, how the stack is behaved, the same thing here we using. The same concept here we using. Or here we applying. Okay, the same concept here we applying. So then only here we name it as a stack. Okay. A deck of cards or pile of plates. Okay, so these are under some examples. Okay, in this way we can store many items one by one. Okay, so that's a real world stack allows operations at one end only. Okay, so in this stack you can do anything in only one end. That is the top. Okay, you can place anything in the top. You want to remove anything only in the top. So everything in the top position. Okay, but in queue operations, that's separate. Okay, there we have two end. One is the front end and one is the rear end. But here we have only one. Okay, we can do anything. Okay, already we are discussed in our previous video, introduction to the data structures. Normally in data structures, we are performing many operations. We are performing many operations like insertion, deletion, modifications, searching, sorting. We can do many operations. Okay. If we do anything in stack only in the top end, top only you can do anything. That is possible. Okay. That's only here we want to know clearly. Okay. When you are studying about stack operations, you want to know these things clearly. Okay. Here that is called as LIFO. Okay, LIFO. This feature makes it LIFO data structure. Okay, that's a LIFO stands for last in first out. Okay, which one you are placing in that stack last, that should be removed or take as a first. That is the last in first out. Is last in first out. Okay, here the element which is placed, that's instead or added, inserted or added, last is accessed first. Okay, which one is inserted or added last, that will be accessed first. In stack terminology, insertion operation is called push operation and the removal operation is called pop operation. Okay, in stack we are performing two major operations. One is that's an insertion, adding. That operation is called an push operation. Another one is called an pop operation. Okay, second one is the pop operation. Okay, that you can see that example diagram. Okay, you can see this diagram. Okay, the following diagram will stack and its operations. Okay, see this. Uh, Normally we are performing push operation. Okay, we are add the data element one by one. So the first added element is available in the last. Second added element is available top of the last. So in this way, we place all the elements one by one. Okay. So there is a push operation. Okay, adding is only with the help of push operation. If you want to remove, if you want to remove, so there is a pop operation. Okay. So see here, we are executing the pop operations. You removing every element, from the stack. So that is called a pop operation. Okay. So stack can be implemented by means of an array, structure, pointer, and linked list. Okay. So if you want to implement this concept in any one of the programming language, you can easily do this. Okay. How it's possible means you need an array, structure, on the pointer, and then linked list. These concepts, which language in these facilities, you can easily implement it. Stack can either be a fixed size or fixed size one, or it may have sense of dynamic resizing. Here, we are going to implement stack using arrays, which makes a fixed size stack implementation. If you implement using arrays, that is a fixed size. When you are using linked list, if we are using linked list for implementing the stack operations, that may be a dynamic. Okay, that may be a dynamic code. Okay, so you can add any number of elements in the stack. Okay, but if you are using an array, initially you want to fix that size. Okay, 20 elements, 30 elements, 40 elements. So you want to fix it. You want to finalize it. Okay. So that's important thing, guys. Okay. So here you can see now the basic operations of stack. Okay. Stack operations may involve initializing the stack, using it, and then de-initialize it. Okay. Apart from these basic steps, a stack is used for the following two primary operations. One is a push operation, that is storing. Pushing is nothing but a storing. Then pop, that is removing. Okay, it's removing for accessing an element from the stack. These two are the very basic operations for stack. Then apart from these two, another three operations are there. One is peek, get the top element of the stack without removing it. If you want to know which one is available in the top, you can use this method peek. After that, if full is there, if empty is there. If full means check if the stack is full. If empty, check if the stack is empty. Okay, these two are very important operations. When if these two are very important means, if you insert an element, if you insert a new element into the stack means, you want to check if is it full or not. If the stack is already full, how you can add another element inside the stack? That is not possible. Okay. So therefore, before inserting element or storing an element inside the stack, you want to check. You want to execute the operation is full. Okay. Let's say or vice versa. Whenever you want to remove an element from a stack, you want to check is empty or not. If there is no element in that stack, means how you can remove an element from a stack. That also not possible. Okay. So therefore, these two operations is full and is empty is executed before executing the pop and push operations. Okay. Okay, students, now I think all of you clear with this. Okay, till now we discussed about what is a stack, how it's important in the data structures. Okay, how we are using the stack, how many ends are there, where we are, which end we are inserting an element, which end we are removing an element. So everything. Insertion, deletion, everything performed only one end. That is called a top of the stack. Okay. Okay, students, that's a very important thing. You want to concentrate more and more. Okay. Next, here we have one more sample code for the function peak algorithm of peak function. Okay, so you don't worry about this. Okay, it follows some languages. Normally, we using only C language. Okay, the code is available here. You can concentrate. It's a very familiar language, C language. Int peak of return stack of top. Okay, stack is like an array. Okay, here the top element. Okay, which one is available in the top? That should be returned. Okay, that should be returned. Okay, we can't remove or insert anything. Simply we retrieve it. Simply we retrieve the top element. Okay, so there is nothing but it's not a deletion. It's not a storing. It's simply retrieving. Simply we show that which one is available in the top. That is the main advantage or main usage of the peak function. Okay. So next we see that code for is full. Okay, is empty. Okay, see the C language code. Okay. So simply we see that on where I move that mouse in that particular part. Okay. So in that bool, that is the boolean value. Okay. If it is full means it will return true. It's not full means return false. Okay. So therefore here we return type is. We mentioned the return type is bool. That is a boolean. The is full is the function name. See here, is full is the function name. Then if top is equal to max size, return true. Else return false. Okay, so that's a very, very important function. Okay, whenever we get the result is full, true means we can't execute the which operation, push operation. Whenever we get the result, okay, is full, not a full. Okay, so therefore we can insert the element. Is empty also the same. Okay, see the code, C language code for executing the is empty. See this, if top is equal to -1 means there is no element. The stack is empty. So we can't execute that delete operation. That is pop operation. Okay. Next, push operation. Okay, see, push operation is working in which way or how we want to execute this. Check if the stack is full or not. If the stack is full, produce an error and exit. We want to intimate the stack is already full. We can't insert any value. After simply we exit. If the stack is not full, increments the top value to point next empty space. Increment the top value, and also you can store the next empty space. Adds a data element to the stack location where the top is pointing. Next, return success. The element is successfully inserted. There is a push operation. See this. This is already available stack, existing one. In this stack, already 4 elements are inserted. That is A, B, C, D. Now we want to insert the fifth element E. Okay, here we check the stack is not full. So therefore, we increment the top value by 1. Top is equal to top plus 1. So it is point out here. The top value is point out here. In this place is empty, so therefore we add the element E. So the resultant stack is like this. Okay, here we add the element E in the top position. So therefore now the stack contains 5 elements. Okay, so before inserting the element E, the stack contains only 4 elements. Now the stack contains 5 elements. That is the output and output after executing the push operation. Okay, so after executing push operation, this is before executing the push operation. Okay, so here we have that algorithm. Okay, here we have as a push also an operation or a method. So it needs some code, C language code. See here, it's normal procedure, general format. It's only a C language code. Okay, so therefore void push off into data if is full means not is full means you execute it. Otherwise, you can print this. You got insert data, stack is full. It's very simple operation, students. So if you execute as a whole program, you can understand. Before that, you want to know each and every operation, how it executes, how it's important. This push operation is how it's important for our stack operations program. In that way, you want to know each and every operation. Okay. Finally, you can combine all the code. You will easily get the whole program for stack operations. So next one is very important operation, that is pop operation. Okay. So it is very useful for removing the element for access. Okay, you can remove it from the stack. Therefore, first we are using the pop operation. And you see here that algorithm is there for pop operations. 6, if the stack is empty. If the stack is empty, produces an error and exit. The step 3, if the stack is not empty, access the element at which top is pointing out. The stack is not empty means you can retrieve the element from the topmost. You can remove the topmost element and reduce the top value by 1. Top is equal to top minus 1. Okay, then return success. Successfully, the top element is removed from the stack. Here, so our previous example, okay, here we have 5 elements in the stack. Now we are removing the topmost element E. What we do? We reduce the top value by 1. Okay, the top is equal to top minus 1. So automatically the top step down by 1. Okay, it's moved to 4th place. So automatically you can remove the element. You can see that memory space. Automatically the E is removed from the stack. It's a C language code for executing the pop operations. Here int pop off into data. Then if not is empty, you can remove it from the stack. Otherwise, there is no element in the stack. You simply show the message. Okay, students. Okay, finally, what we expect means the whole program that is now available. Our expected thing is available now. Okay, that is the whole program for the stack operation. Okay, implementation. The stack implementation in C language using C language. As usual, you know that as include std.h, there is a normal inclusion, file inclusion, or the direct inclusion code. Then integer max size one variable is there. Int stack of 8 on array is declared. Then int top is equal to -1. Okay. So in this way, 3 variables are declared. After that, we include the code for is empty. Then you can include the code for is full. Then peak, then pop, and then push operation. Okay. This codes already we know in our previous slides. Okay. Finally, you can write the main function. First, you can include just you can call the push operation 1, 2, 3, 4, 5 times. After that, you want to display the elements. Finally, if you want to remove the element, means you want to execute the pop operation. Here, you're executing the pop operation. Okay, so in this way, we can execute easily about stack operations. Okay, students, I think now all of you have some idea about this stack operations. Okay, still now we are discussed in a detailed manner about all the areas of stack operations. Okay, initially, we see about what is the stack, then how we implement that stack, how it's very useful in the real world. Okay, we saw some real world examples also. After that, how many ends are there in stack. Okay, we already see that. After that, how we execute the push operation, pop operation, and then what's the importance of is full, is empty. In this way, we covered a lot of topics in this video. I think it's very useful to you. Okay. So students, in the next video, we will see about queue operations. Okay. Okay. Thank you.